Hey guys, did y'all know that I found out something very interesting yesterday. Did y'all know that the black holes they dissipate with time? Like it is very slowly, but they slowly lose their mass and they start becoming uh, radiation. They become, what's the name of it? Hawking radiation. I found that like very interesting because in the far future of the universe, like when there is no more planets or stars, not even the black holes will like still be there because they will have dissipated and become radiation.
That's actually really interesting. Could you tell me more about like the black holes? Because I also find it interesting, but I haven't done much research of it.
Okay. Like I know an interesting fact. It is like the black holes. It is ironic, but they are the brightest object in the space out there in the outer space.
But
Even though
how?
they suck, even
Every
though
time I see them in the pictures, they're like pinched black. How are they so bright?
okay, so like they are very dense. They have they are the objects with the like strongest gravitational force.
Yeah.
So basically, not even light can escape them. So when you look at them, their center, oh, right, you see a like a sphere. If you looked through a telescope, like a very strong telescope, like James Webb, you would see a bright sphere with like very bright. There is a circle. It's not a sphere, a circle. A very bright circle with a pitch black center. Because there is a black hole in the center, and then there is spinning, like spinning on it. There is light, and there is also matter, like matter
Yeah.
from other stars or nebulas or any type of matter that is in outer space. They like caught it, and then the gravitational force is so strong, but the matter is also fast. So it starts spinning, and it spins so fast that by friction, their temperatures are so high they become plasma, and they kind of produce their own light in this process. So it's the light that the black holes kind of they catch in the outer space, but also this matter that is uh, so with such high temperatures that is it create its own brightness, its own light.
Damn. I heard a rumor. Like I've seen somewhere that we orbit. We our galaxy actually orbit a black hole. Is that true?
Yeah, like if you notice like how the galaxies like they're kind of a draw, like they have their
Yeah.
arms. It is like normally a spiral. It's because each one of the spirals are like its constitution is like basically other stars and other solar systems and anything like that. And the center of the galaxies are a very supermassive. It's normally a supermassive black hole, and all these stars are orbiting it. And the star we are like orbiting the sun, and the sun is orbiting a, a black hole. So we normally think in like the model of the solar system. We think like we tend to think that the sun is stationary, but it is actually moving really fast. If I'm not mistaken, I think it is like 1,000 kilometers per second, something like that. It
Damn.
is very fast. It is very fast. I forgot to mention even like in the last example what I was talking about, this circle around the black hole that is like matter and light. Its
Yeah,
name is
yeah. It gives like
accretion disk.
the pretty appearance. Yeah, yeah. I've seen
It is
pictures.
accretion disk. It's the name of it.
Oh, and I don't know if you told me earlier, but what does this accretion disk has? like in its composition. I don't think you mentioned it earlier.
I
Did you?
mentioned it. Like, it has like matter from other stars, that stars, nebulas, any type of matter, and light that the black hole it catches because of its attraction, gravitational attraction.
Yeah, but like a question has spawned in my head. How does this accretion disk not get like swallowed by the black hole? Because like it's huge
Oh, so
gravitational
yeah,
force. It would be like sucking everything.
yes, because like this matter is traveling already in space, like at very high speeds. So until they cross the horizon event, that it eventually can't escape. Like it will be a little bit farther because it's not light, it's not moving at speed of light, but it's really fast. So it keeps going around it until it comes to a point where it falls and it can escape because the matter is already traveling at very high speeds. So they are trying to escape the gravitational force, but they
Hmm.
really can't. The matter is like trying to fall into it, but they really can't because they are moving at such high speeds.
Yeah, it's fighting for its life. So, like, could you tell me more about like the how this black holes come like to I don't know how to live, because I don't know like its formation. I don't know how they're made of. I just heard some rumors like here and there, but I'm not really sure.
Yeah, basically, it's very crazy to me. Also, I really think it's very bizarre. I really don't. I really can't understand how it happens, and I really question if it is real or not. Because basically, when a very supermassive star, a very big star, it dies, it collapses, and all the matter that was ejected into the space, like it exploded, and then the
Yeah.
all the mass was like uh, throw out there. But then its own gravitational force starts pulling it together again. But it's so much matter. The gravitational force is so big that it all comes to a very small point and it becomes a singularity. Singularity is basically uh, as a point of space that basically its volume is almost zero, but its density is basically infinite, which is very crazy to me because
Yeah, it
I
doesn't make sense to me. It doesn't make sense because like density we calculate it by dividing mass by its volume, so it doesn't really make sense to me.
yeah, because like it was something before it was a star. It didn't have all that gravitational attraction, but
Yeah.
then after it died, it collapsed and became a black hole with a much heavier, a much more intense gravitational force, and it like created a singularity in it. And I really cannot fathom how this is even possible. But that's how it is. That's how the science says it works. So I guess we need to accept it. It's
Yeah.
something very intriguing to me, and that's why I'm so fascinated by this theme uh, because it's so crazy that something like this can even exist in the universe.
Yeah, like it doesn't enter in my head like a concept like that. It's like I don't know, like magic, fantasy. But I was doing some research here, and they mentioned something called white dwarf. Do you recognize the name? I don't know.
Oh, I do. It's like a type of star. It is a white dwarf. It's very small,
Yeah,
um, very small star. It is white. That's why its name. It's white dwarf.
yeah, yeah.
But it also has like, if I'm not mistaken, uh, also and very big, a good gravitational force. It's not nothing like a black hole.
Yeah,
And
yeah,
I think they because like stars they have their stages of life. They
yeah.
they
Like
even
the
change
red
colors.
giant and everything like that. Yeah,
Yeah, they like change colors in the course of their lives because they the stars are basically doing nuclear fusion, right? You know that.
yeah, yeah. I heard
And
some about that, like nuclear energy. We
yes, yes,
could, but that's not possible on Earth, like the fusion on the fissure.
it is. It is kind of possible, but it's very hard to do. That's why like there's scientists trying to make a viable way of us
Yeah,
doing
and we need
energy.
like a specific element, like helium trees. That the
Yeah,
name?
yeah, yeah. But this element is not like found on Earth because
Yeah, exactly.
the the atmosphere it protects it like prevents this element of getting here because like the element has to go through all the electromagnetic field and
Mhm.
the atmosphere. So a place where we could find this element is on the moon because it doesn't have uh, an atmosphere. But
Yeah,
for us to go to the moon, get this element, and come back to Earth, like very what expensive. So it's almost inviable.
yes, I
And
see.
that's why like the scientists that tried to discover another element, another variation for this, another alternative for this element.
Yeah. So, coming back, like to the going back to the black hole topic, I heard something called a black hole. I don't even know if it's a black hole, but it's something similar called Tom 618. Do you know anything about it?
Excuse me, what?
Tom 618 618.
Oh, it's like one of the largest black holes out there. It was considered the largest, but then recently they found out about the existence of the Phoenix A. It's the name
Yeah,
of it. It's
yeah,
like
I
a
think so.
very much larger, and like these objects are so big that we cannot fathom how big they are. Like a normal human, we already cannot fathom like the type of the size of the sun, and they are many times bigger than the sun.
Many suns could fit inside of it. Yeah, I see. So like one, I don't know if it's my last question because this topic also makes me question like my whole existence. But is the sun going to be like a white dwarf or like a black hole?
Our sun?
Yeah, our sun from our
Oh,
solar system.
it's not big enough to become a black hole. It's definitely becoming a supernova. No, supernova, not. I'm sorry. It's definitely becoming a white dwarf.
Yeah, yeah,
Only the very big stars become can have the capabilities of becoming uh, black holes.
yeah. I heard like I was watching like a video earlier that said like if its star has 8 times the mass of the sun, it will explode into a supernova. And like if the core of this star, if it's like 3 times the mass of the sun, it will become a black hole. I heard that on a YouTube video in a YouTube channel that I found really interesting. So I thought it would be good like to bring some information here.
Yeah, that's correct. I think I know what channel is it. What is the name of it?
Like I think was maybe Space Today, something like that.
Oh, I know it. Yeah. I think I also like this channel a lot. I remembered
Yeah.
something. We were talking about the biggest black holes in the universe, and like people, there's a lot of people that think they're scary, but like they are the least. They are the ones that represent the least. Uh, what is the
Threat.
word?
A threat.
Yes, exactly. They're like the one that represent the least threat
I see what your point. Yeah, I see.
because
So
for example they are big, so like it is their gravitational attraction is like very vast. You know, it is very uniform, and it doesn't like vary too much from a point to another. When it is very tiny, like if you were in a ship traveling through space,
Mm-hmm.
the if you came too close to it, it probably could shatter the ship only by the gravitational force, and you didn't really need to go too much close to it, because like the difference between the gravitational force is so different from one point to another, then it would literally just destroy your ship just by you walking past it.
Yeah. Oh, I remembered something. You remember like the channel that I told you like 2 minutes ago?
Hmm.
So I was watching a video of him, and he told me like about a theory about something called a wormhole. Do you have? Do you recognize?
Oh,
Uh,
yes, yes, yes. It is very popular in like pop culture. Um,
it's
it
like
is
time
basically
traveling, or what? Like the 1 minute
yeah,
episode.
because we don't really know what happens to something that falls into a black hole. There are many theories, and one of them is like this what you're talking about, the wormhole.
Yeah,
It has another name.
it's
Its
distorts
name is
time
the
and time and space. It's really interesting.
yeah, its name is like the Einstein-Rosen bridge, if I'm not mistaken.
Yeah, 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 yeah. It's like a technical
You
name.
have this theory that there's the black holes and there's another object in another point of space that is the white hole. So basically, the black hole is where you enter from it, and the white hole, like instead of sucking all the matter into it, it like expels it. It's like almost negative
Yeah,
gravitational attraction.
damn. But oh, yeah, that's just a theory. No, but
Yeah, it's only a
like,
theory. I don't think I really believe in it, but it's there.
yeah, like I don't like the concept is cool, but like it doesn't. According to science, that like wouldn't make sense. Like it's negative. What you say earlier? Negative attraction.
Negative
Like
gravitational
how?
attraction. Like it, re- instead of attracting, it repulses.
Damn. Like as you said, like the word repulses, and something came to my mind. Like I was doing like school research, and like pulsar appeared on what I was searching for.
That's a topic that I don't really have that much knowledge about it, but I do know some things about it. So basically, the pulsar is a name of to the scientists very early in science, when people were studying about the not that early, but some years ago, when they were studying about the objects in the sky and stuff like that, they noticed that there was like a star or something like that, that its its brightness, it like changed very, it varied very fast compared to anything any other stars.
Yeah.
uh, because like it pulsated. That's where the name comes from,
Uh huh.
pulsar.
Yeah.
There were scientists, because like there is many times where a star changes brightness, because like for example they have a planet orbiting it. So when the planet goes in front of it in relation to us, like it is in front of the star, so it blocks a part of the light that is coming to us, so it looks like it, like the brightness low and got lower. But the pulsar is something very different. It's like it is a neutron star, where
Yeah.
it's
Yeah.
another thing that a supermassive star can become, different from black hole. It is when you know like how the atoms are constituted, right? You have the protons, electrons, and the neutrons, right?
Yeah. Yeah. How atoms are made of? Yeah. What
Yeah.
atoms are made?
Basically, the neutron stars are when like a star collapses, and the gravitational force is so strong that it overcomes the the forces of an atom. Like like the electrons, they repulse each other, and like the same when you have the same
Yeah, like it's
magnetic
negative, negative. Yeah, I see.
negative negative, they repulse each other. Positive positive, they repulse each other, and when like positive and negative, they come together, right?
Yeah, like
Basically,
yeah.
uh, the gravitational force is so strong they like can bring all the particles of an atom and like compress it together. They like overcome this magnetic part of the electromagnetic part of the atom. So it all becomes one thing that it is basically just neutrons because you had the positive and the negative, and it all basically is kind of cancel it out and becomes all neutrons, and it is very very dense, and like the pulsar comes from like in their poles. You have like the north and the south pole, right?
Yeah, uh-huh.
They have like a beam of light coming from each one of these parts. I That's where the part I don't really have the knowledge about it because I don't know why it happens, but I know it is like that. Like they have a very uh, a straight a beam of light or whatever. I don't know what it is, but like it is rotating. So when it looks like a pulsar to us because these beams that are basically light, they go from a side to another, spinning very fast. So from our perspective, when this beam is directed to us, it is very bright, and then when it like goes to another direction, this brightness lowers down. That's where the this pulsating effect comes from.
Damn, that's like very complex, you know. So that's why scientists uh do some research of that like their whole life during their whole lifetime.
Yeah, it's very complex. I
So
really wanted to search more about the neutron stars. It's another thing that really gets my attention.
yeah, it indeed does.
All right, guys. That was it for today. Thank you for tuning in, and stay tuned for other episodes we might release. Pretty interesting stuff coming up. Uh, and that was it. Hope you guys enjoyed, and that's it. Bye bye.